So good morning friends. So in the continuation of my previous lecture, calculation of beam warping and sectional warping machine. So in this lecture I will discuss about the calculation of sectional warping machine. So here we are going to calculate time required to produce weaver's beam on sectional warping machine. So we will take some of the fabric parameters. Width of the fabric, let us say it is 54 inches. Length of fabric 5000 meters. EPI, let us say it is 62, and crimp and warp around 5%. Other machine parameters, maximum creel capacity, let us say it is 320. Machine warping speed, let us say it is 600 meters per minute, and the end breakage rate let us say it is 2 breaks per 1000 ants per 1000 meter. So these are some of the machine and fabric parameters. Now we have to calculate reed space, tape length, total number of ants, number of sections, number of ants in one section, and section width. So here the end breakage rate is 2 breaks per 1000 ants per 1000 meter, and the time required to mend a break is around 20 seconds, and time required to change a section, let us say it is 1.5 minutes, and the beaming speed, as you all know this, that in case of sectional warping machine, it is a conversion of sections and then we prepare a weaver's beam. So the intermediate part is sections. So first we have to prepare sections, and then by combining by all these sections we prepare a weaver's beam. Because we here the creel capacity we have only 320 cone holders, but we need a large number of ants in weaver's beam. So we have to prepare sections, and then by combining n number of sections we prepare a weaver's beam. So the beaming process is when we first wind all the warp threads on dresser drum. First we will prepare sections, and by combining all these sections we prepare a weaver's beam. So here beaming speed is when we transfer all the sections from dresser to weaver's beam, that is beaming process. And let us say the beaming speed is 200 meters per minute. So now we have to calculate reed space. As you all know that reed space is fabric width and crimp. So here we have 54 inches our fabric width, and the crimp is 5%, so it is 56.7 inches. And tape length, that is fabric length multiply by crimp, and that is 5000 multiplied by 1.05, and that is 5150 meters. Here we have taken crimp and warp and waft 5%. Therefore, in case of reed space we are adding 5% crimp, and in case of tape length the crimp is same 5%. Now the total number of ants, that we can find out from the fabric width, which is available in inches, 54 inches, and API, ants per inches. So that is 54 multiplied by 62, and that comes 3348. So 3348 ants are available in weaver's beam. Now we have to calculate number of sections required to prepare a weaver's beam. So number of sections we can find out by dividing total number of ants by our maximum creel capacity. So here we have 3348 number of ants, and the creel capacity is 320, and it comes around 10.46. So we have to prepare 11 number of sections, because it's 10.46, so it is going towards the 11. We cannot prepare 10 sections because we have maximum creel capacity 320, so we have to increase number of sections. So here we will take 11 number of sections. Now we can calculate number of ants in one section, and that can be done by (3348) divided by 11, and it comes around 305 ants. So only 7 ants are increasing, so we can reduce 7 number of ants in the last section. Now we will calculate the time required to prepare one section. So here we have machine parameters. Our machine speed is 600 meters per minute, and the total length, tape length, is 5150 meters. So that is equal to tape length in meters divided by warping speed. So that comes 5 to, sorry, this is 5 1, this is not 51520 50, it is 5250. So 5250 divided by 600, and it gives us 8.75 minutes. So here we need 8.75 minutes to prepare a single section. Now we will calculate the time required to prepare or mend a brake. So here we have taken in breakage rate, that is 2 brakes per 1000 ants per 1000 meter. Now we have total number of ants 5250, and we have we have total number of ants 3348, and the length is 5250. So we can find out number of ant brakes in one section. So here we have 305 ants. Length is 5250. So we can find out number of ants breakage during one section. So here 2 brakes per 1000 ants, but here we have 305 ants, so the number will decrease. And here we have 3348 number of, sorry, we have already taken 305 ants in one section divided by 1000, and we have 5250 meter length divided by 1000. So this will give us total number of ant brakes during one section. So that is 2 multiplied by 305 and multiplied by 5250 divided by 1000 divided by 1000. So this comes 3.20 brakes in one section. So when we multiply it with the time required to mend a section, that is 20 seconds. So time required to mend a brake, that is 20 seconds. So total time required 20 multiplied by 3.2, and that comes 64 seconds. So now we have time required to prepare a beam, that is time required to prepare a section, that is 8.75 minutes. Number of ant breakages 3.2. Time required to mend a brake 20 seconds. So now 64 seconds are required to mend all the brakes during one section. The total number of sections are 11. So now we can calculate time. So 8.75 minutes are required to prepare one section. Here we have 11 sections, and the time stoppage time is 64 seconds multiplied by 11. So this is our stoppage time, this is our running time. Also we need 1.5 minute time to change section. So the total number of sections are 11, so we need to change it 11 times. So we can multiply 1.5 by 11, and that gives us 16.5 minutes. Now we can calculate efficiency of whopping machine. That comes running time divided by running time plus stoppage time. So running time is 8.75 multiplied by 11, that is our running time. This is our stoppage time. This is also stoppage time. So 8.75 multiplied by 11 divided by 64 seconds multiplied by 11 plus 1.5 multiplied by 11. 93.5 minutes. Here we have in seconds. So 64 multiplied by 11, that is 704 seconds. I'll divide it with the 60, so that comes 11.7 minutes plus 11.5 multiplied by 11, sorry, 1.5 multiplied by 11, that is 16.5. This is our stoppage time, and we have to add running time, that is 93.5. This is stoppage time, this is stoppage time, this is running time. This is the calculation of our efficiency, running time divided by running time plus stoppage time. So this is our running time, this is stoppage time, this is stoppage time, this is running time. So the total time is 11.7 plus 16.5 plus 93.5. So that comes 93.5 divided by 121.7. So the efficiency 93.5 divided by 121.7. So that is 7.768, and when we multiply it with the 100 then this will give us efficiency in percentage. So 76.8% efficiency. So this way we can calculate efficiency of sectional warping process. So thank you very much, students. So in the next class I'll discuss about the calculation of beam warping machine and the efficiency of beam warping machine. Thank you.